So, today we are graphing quadratics. Now, let's just refresh our memory again. What's a quadratic?
It's a quadratic.
What do they have in them?
Four-term polynomial. No. A polynomial.
I haven't heard a right answer yet. I heard a lot of...
With the exponent raised to 2.
Yes, your exponent has to be raised to... It doesn't matter how many terms you have. You can, guys, listen. You can have a one-term quadratic, a two-term quadratic, a three-term quadratic. You can have a four-term quadratic. It's the exponent. So these that we've been working on for some time now, those are quadratics. But it's a quadratic because the highest exponent is 2. Not because it has 3 terms. Because look, if I took that 2 off, it's still a quadratic. It just has 2 terms now instead of 3. That's all. Now, anytime you graph a quadratic, yes, the shape that comes out is a parabola. So I know we've talked about this a little bit already. So you have parabola is a fancy word for a U-shape. Parabola. And there's a couple of things about a parabola that I know we've mentioned before. This point right here is called the vertex. It is also really sort of your I don't know, it's like your middle point of your whole graph. In other words, right through the vertex, you have what we refer to as the axis of symmetry. So if you were to fold a parabola along the axis of symmetry, it would line up perfectly. You remember symmetry from elementary school, I'm sure. Perfect. So there you have it. Parabolas have symmetry. What is so nice about that is when you're graphing them, you can use that axis of symmetry like a buy one, get one free sale. You can do the math to find out this point, but then you don't have to do the math to find out this point. You bought this one, you're going to get this one for free. You just mirror it over your axis of symmetry. So we get to do half the work for parabolas, which is very nice because they are all symmetrical. Okay? A few other things to mention. If your parabola is, I call this up like a cup, because your alternative is down like a frown, right? If it's flipped the other way. This vertex, isn't that the lowest point on the whole graph?
Yeah, but it can be the highest.
Right. So in this case, it's called a minimum. But if I had my parabola the other way, my vertex would be a maximum. It's still called a vertex, but in this case, it's the maximum point of the whole graph. That would be a maximum. Okay, all of our parabolas are either going to be up like a cup or down like a frown. And I claim that you can tell if it's going to be up like a cup or down like a frown just by looking at the equation. There's not really any math involved. You just have to look at it. Where am I looking? Well, I'll tell you. Your generic form of a parabola, or of a quadratic, is ax squared plus bx plus c. So you know how we've been talking about a, b, and c for a long time? Right? This would be a, this would be b, this would be c. So the value of a tells us an awful lot about your parabola. Yeah. So if a is positive, the graph is up like a cup.
What?
Up like a cup.
I didn't even write the word graph.
I mean, you could say parabola instead of 2. So, as long as a is any positive value, it doesn't matter. It's positive, up like a cup. So naturally, if a is negative, the parabola is down like a frown. I cannot tell you how many times a student will turn into me a graphing quiz and they don't at least check this part. You know from the jump if it's going to be up or down. So if you know, if I ask you to graph this parabola, you know it should be up like a cup because A is a positive value. Don't turn into me something with it upside down. You already know it's wrong. So that one little check is going to save you if you make a silly mistake with the negatives. There's something else that A tells us. Anybody know? Kind of. It tells me how narrow or how wide my graph is going to be. Okay? And that's really all that we can do to these graphs. We're not turning them sideways because then they're not functions anymore. So they're either going to be right side up or upside down, and then they're going to be really narrow or really wide or kind of just normal-ish. So positive, negative tells you up or down. So it's really the absolute value I want to talk about of A. So,
Oh, yeah, okay.
you know what? Because like -5 really is smaller than 3, but I want to talk about 5 and 3. You know what I mean? So, if the absolute value of A is bigger than 1, what do you think happens? The bigger A gets, what happens to my graph?
Gets wider.
That's always everybody's guess. It actually goes the other way. It gets more narrow. Yeah, because it's not really slope, but it's to get from one point to your next point, you're going up more. So anyway, it does become a more narrow graph. So if A is greater than 1, the more narrow the graph will be. So if you were to compare, for example, let's just say x squared and x to the 5th. X squared will be something like that, whereas x to the 5th will be something like that. So you'll be able to see that the bigger A is, oh my gosh, dopey, that's, why didn't you guys say? Miss Sabia, A is the same in both of those. I meant this, 2x squared and 5x squared. That's what I meant. Oh my gosh. April Fools. So, could you imagine if I had y equals 100x squared? Now you're talking ridiculously narrow. Okay? So, the bigger A gets, the more and more and more narrow your graph. Okay? So, conversely, if the absolute value of A is less than 1, so give me examples of numbers that are less than 1. Absolute value is less than 1.
Zero. No, none. Because absolute values are always positive. Oh, zero. Oh, no, unless you have a negative sign on the outside of that.
A half.
Oh.
There was some good conversation there, though. But these are your fractions between 0 and 1. A half, a third, a ninth, 2/5. Okay? So, because remember, the sign just tells you up or down. So -2, I know is less than 1, but that just means it's going to be upside down an arrow. Right? So remember, you're thinking absolute value when we're talking wide and narrow. So these are your fractions, less than 1. Okay? So if A is less than 1, the graph will be wide. Along the same wavelength, the closer it is to 0, it's going to be wider. So in other words, 1/4 will be wider than 3/4. Well, I'll put an example of that. So say I had 1/4 x squared versus 3/4 x squared. 1/4 x squared will be quite wide, and 3/4 will be wide, but not as wide as that. Maybe something along those lines. So what happens when A just is 1? Well, we don't really, that's sort of our middle point. We're not calling that particularly wide or narrow. That's our starting point. Okay. What do we think so far? So, if you look at this worksheet, let's just talk about these first 6 graphs. If you look at number 1, tell me what you know about number 1 already. It's up like a cup because A is positive. Is it going to be wide or narrow or not? I usually say wide, narrow, or neither. Neither, because A is just 1, so that's just going to be a normal U-shaped graph. If you look at number 2, tell me what you know. Down like a frown, and it's not particularly wide or narrow because A, the absolute value of A is just 1. So these two, now here's, I hate this particular software because they change the scale on you. I wish that these, you get what I'm saying? Like I wish each grid were identical. Because if you were to graph 1 and 2, they would be the exact same width. It would just be that this one's upside down. And they're in different spots on the coordinate plane, but it would be the same U shape, just one's up, one's down. I'll get there. 3 is the same thing as 2, but tell me what you know about 4. It's up like a cup, and it's going to be wide. So if you compared your graph of number 4 to number 1, for example, number 4 should certainly be wider than number 1 is. Again, they're changing the scale on us, so it may not be as obvious, but whatever. 5, tell me what you know about 5. It's up and narrow. And then 6 would be does anybody besides Danielle know what's going on here?
I don't understand how you tell if it's narrow or not. The sign's not there.
You're looking at A, right? A in this case is -3. Because it's negative, that means it's upside down. And then ignore the sign, you just look at the absolute value. So the absolute value of -3 is just 3. Anything bigger than 1 will be narrow. And the bigger it is than 1, the more narrow it gets. So if I were to compare my graphs of number 5 and number 6, who would be more narrow? 6. The bigger A is, the more narrow that gets. Okay, so you've actually answered A and B for this first 6. See at the top, I tell you to find all these things. So there's A and B. The next one, find the vertex, this is a big deal. That's really where you're going to start. A and B, yeah, you told me something about the graph, but you didn't plot any points. So, finding the vertex, that's usually the first point that we plot. Okay? So, how to find the vertex.
The vertex is Y.
No. So, the vertex could be anywhere on the coordinate plane. You just have to find its location. So, I need to find the ordered pair where the vertex is gonna land, okay? It's pretty easy once you get the hang of it. Everybody ready? And you're gonna see something that may look familiar to you. I don't know, maybe it does, maybe it doesn't. I don't know, we're gonna see if it rings a bell. You ready? So the first thing you're gonna do to find the vertex is you are going to find the value of -b over 2a. Think on this. Where have you seen yes. The quadratic formula.
What an old friend.
You are so right. Let me just jump back and refresh your memory what the quadratic formula looked like. Well, what do you know? Didn't you have a negative b over 2a? So, what the quadratic formula really is, when you put this all together, this gets me the x coordinate of my vertex, and then I just add and subtract the square root of the discriminant from it. So, negative b over 2a, again, if you know the quadratic formula, you already know negative b over 2a. You just have to remember it's just that piece. So when you do this, right, when you calculate negative b over 2a, I just told you what it's going to get you. This is equal to the x value, or the x coordinate, sorry. The x coordinate of the vertex. So, if I'm just looking at number 1 on your worksheet as an example, I'll just recopy it over here. Y equals x squared plus 2x plus 4. Okay? So, if I wanted to do negative b over 2a, you guys know how to find a, b, and c, right? It's the same way we've been doing it this whole time. So, what would negative b be in this case? What? Negative 2 over 2 times a. What's a? 1. Right? A, B, C. So when I do negative 2 over 2 times a, that's negative 2 over 2, I get out a negative 1. Is that okay with everybody so far? That right there is, your vertex is going to be at some x comma some y, right? So that's the x coordinate. So now you know that your vertex, you're halfway there. It's going to be at negative 1 comma something. That's what you just found out. When you do negative b over 2a, it gives you the x coordinate. How do you suppose you find the y coordinate? Nope. C, we actually kind of ignore here. Well, I guess I don't. I take that back. I'm not going to ignore C. I do need it for something.
You do need it. I just forget this for
Yeah, that's it. Take negative 1, right? And I just want to see what is the value of y when x is negative 1. So I plug negative 1 back in, and I'm just going to figure out what y is. So that's step 2. So take that answer and plug it in for x to get the y coordinate. So that's all I have to do. Y equals negative 1 squared plus 2 times negative 1 plus 4. So if I just do that math out, that'll give me the y coordinate. So that's 1 minus 2 plus 4. 3? And now I have the coordinate for my vertex.
Wait, can you put it down? Oh, wait,
Everybody sees how that worked? I did negative b over 2a. That gives you the x coordinate. Then you have to plug it in to your equation for x and see what y is. So now, if I'm out working on this worksheet here, I'm going to put my first dot, my vertex, at negative 1 comma 3. Negative 1, 3, there it is. Unfortunately, with the vertex, you don't get to buy one free on the vertex because that's on the line, right? So I don't get to mirror over it. If you want to draw your axis of symmetry, you can draw it right through that vertex. That's fine. When you have the vertex, you also have the equation of the axis of symmetry, believe it or not. I just drew it. If I ask you what the equation of this vertical line is, what would you tell me?
Negative 3. 0. Negative 1.
Wait,
I
hold
was
on.
I've heard a bunch of numbers so far, but I haven't heard an equation of a line.
X equals -1.
Oh, there it is. X equals -1. X equals -1. X equals -1. So, let's just, let's throw that on here. So, big star somewhere in your notes. The equation for the axis of symmetry is always X equals, you have to write X equals, just like that. X equals the X coordinate of the vertex. So if you have already found your vertex, you already have the equation of the axis of symmetry. You just have to write X equals and then whatever the number is. So X equals -1 would be correct on our example here. Okay, so if I'm looking at my example, let's see. So far, I forgot to write these things down. Was this graph up or down? Up. It was neither, because it's not particularly wide or narrow. C, the vertex, we found it was going to be -1, 3. And now you're ready to give the axis of symmetry, so you're just going to write X equals -1. You cannot just write -1. -1 is a number. It's not the equation of a line. X equals -1 is. It's a big difference. And you're going to get marked wrong, even if the number's right. You have to give the equation of a line, which is X equals that number. All right. You guys can actually do E already, too. It will be a minimum. How do you know without even graphing it? Right, if it's up like a cup, like we already established, that means my graph is going to come through something like this. So that my vertex is going to be the lowest point on the graph, so it will be a minimum. What's F? Ooh, give the Y-intercept. Now, that's something we haven't done. Y-intercept. Well, we have, just not for parabolas. How would you find the Y-intercept?
Take the y equals 1 minus 2 plus 4 and all that. Because we plugged in the x value already.
Easier.
No, wouldn't you take the c?
Yeah, basically yes. So, let me ask you this question, ladies and gentlemen. Let me draw you a picture here.
Take the opposites. Wait, where's my x?
Not here. So, watch this. Say I had a parabola like this here. And I'm looking for the y-intercept. So, that would be where the graph crosses the y-axis. So, in this case, it would be right there, right? What is true about that point?
It doesn't always cross.
Great question. Because we've talked about whether the parabola crosses the x-axis or not.
No. Because it could be down like the ground, but in like below, or it could be up like a cup above.
So, it doesn't have to cross the x-axis. It can, right? How many times can it cross the x-axis?
2.
Twice. None. Or, is there another option?
No.
Once. If, what does the scenario have to be for it to cross once?
Sideways. Wait, the x-axis one?
Yeah. How can it cross the x-axis once? If it's going to be a U-shape, and it's either going to be up like a cup or down like a frown. If the vertex is on the x-axis, right? So what happens with that, let me just draw you another one. When you have your vertex on the x-axis, what happens right there is that you get you get this answer out, you just get it twice. It's called a double root. So that happens 2 times. You get the same one twice. So it's really only one solution. So that can happen. So now back to Lily's question. She said, will a parabola always cross the y-axis? You have 3 scenarios for it crossing the x-axis. Either it won't cross at all, it'll cross twice, or it'll only cross once. What about parabolas and the y-axis? It will what? Well, it can certainly cross once, like I have in this picture. Are there any other scenarios? Could a parabola never cross the y-axis?
Yes. If it's all the way to the right or it's all the way to the left.
Here's the thing. All parabolas kind of fan out, right? They keep going. This one's going to move more left, and this one's going to move more right. So no matter, even if you put it all the way to the right, eventually this is going to, it just may be a really, really high or low y value. So there will always be exactly one y-intercept. Always. Every parabola will have one and only one y-intercept. But what is true, no matter where it crosses the y-axis, something is always true at that point. Whether it crosses here, or if I had another parabola that crossed down here, or if I had another parabola that crossed over here, if I had one that crossed right at the origin, doesn't matter. What's true at every single one of these spots? I know one of you knows it out there. Put on those thinking caps. What is true about every single one of these spots? That's true. Thank you! Isn't x 0 at every single one of those ordered pairs? X is equal to 0. So that's basically how I find my y-intercept. I just plug in 0 for x. Now, when you plug in 0 for x, what does that leave?
Everything except for the c value.
Yeah, it basically just leaves c behind. Plug in 0 for x. So if I use the example from number 1 on that sheet again, y equals x squared plus 2x plus 4. If you plug in 0 for x, doesn't 4 just come out? So it's basically just going to be your c value. So, and that's pretty much it. That's really, it's like a one-stop shop. So your y-intercept will be at 0, 4. You just plug in 0 for x. And that's everything that they've asked us to list. Now they want us to graph it. So if I look back at my sheet, let's just go ahead and put in point F. We said it was 0, 4. That's a point on your parabola. So let's plot 0, 4. 0, 4. Ladies, gentlemen, buy one, get one free. Now, we're not quite done. I have I need at least 1 or 2 more good points before I have a nice, a good solid base for my parabola here. But you have a choice. If I plug in 1, I'm going to get some value. It's probably going to be up here. And then I can mirror it over, and I get the same answer for -3. You don't have to plug in both numbers. Don't plug in 1 and -3. Why would you? You should get the same answer for each one. So you get to pick. Would you rather plug in 1 or would you rather plug in -3? I'd rather plug in 1 too, because I can do that in my head. If you plug in 1 for x, what comes out?
Y equals 7.
7. So 1, 7 by 1. Now mirror over that axis of symmetry. 1, 2, 1, 2, get one free. There you have it. Now, are going to connect these dots with a nice smooth curve. You will not make a sharp V, because a sharp V is a different type of graph called, what are the graphs with the sharp V's?
It's not absolute. It's
It is.
Oh, it is.
Absolute values have the sharp V's. So this is a parabola. It should be a nice smooth U shape. So do your best to smooth out that bottom. There is a beautiful
Wait,
parabola.
Where do we plug in the 0 when we're doing the y? Do we plug it into the original equation?
Always, yep. You always go to the original.
What if you have a negative x squared? Is that just a full 0?
-1.
You mean like number 3 or 2?
2.
Well, let's do 2 together right now. All right. Well, before we move on, though, was this everything we expected it to be? Is it up like a cup?
No.
Yeah.
Yes, and it was supposed to be. So we're happy about that. It's not particularly wide or narrow. Everything is lining up just like I thought it would. Before you move on, make sure if it was supposed to be up like a cup, like that it is. Down like a frown, make sure that it is down. Okay, let's look at number 2. So let's see. A, will this one be up or down? Down. Is this one going to be wide, narrow, or neither? Neither, because A is 1 again. Remember, the negative just tells me that it's upside down. So the absolute value of A is still just 1, so it's not particularly wide or narrow. So it should be the same width as number 1 was. C, we got to find the vertex. How do you find the vertex again?
Oh, we do -b over 2.
Negative B over 2A. So, be careful. Negative B over 2A. So, everybody get that number out. Don't say it out loud. Just do negative B over 2A. And get that number. Don't say... Mm-hmm. Did everybody get what I got?
Wouldn't it? Yeah.
So far. So now I know my vertex is at -4 comma something. You need to take a moment and find that something. And here, right here, this exact type of problem is exactly where people are going to mess up. So everybody plug -4 back in and don't tell anybody your answer. Just get your own answer. I can't wait to see what we get out for this one. Okay. Did everybody plug -4 back into the original and see what y comes out to be? I'm interested to hear what y's you got.
4.
4, 36, 4. Anybody got something besides 4 or 36? You got 28? 48?
-28.
-28.
4.
4. 6.
8.
Okay, so see how I'm telling you guys, it's right here. If you're going to make a mistake, it's right here. Right here. Let me show you how to do it the right way. So, there were some right answers.
Was mine right?
I don't remember what you said. So, I'm taking -x² minus 8x minus 12. Right? And I'm going to plug in a -4. Please watch how this is done. This right here. See how it says -x²? Do you see that? Let me zoom right in. You see that? See how it says -x²? This means, right here, this means take whatever x is, square it. Are you listening? I feel like we're not listening, and that's how we got 30 different answers. Are you listening? Okay, watch. That means take whatever x is, square it, and then take the opposite. That's what that means. Are you with me? Are you with me? Lily?
Yes.
Okay. Here we go. You're going to take this number, you're going to square it. Whatever comes out, you're going to take the opposite. Ready? So, watch. When I plug in -4, it looks like this. That's the right way to write it. I don't know how you wrote it, but that's the right way to write it. So, you are going to do -4 squared, which is 16, but then take the opposite of it. That's -16 right there. And then you're going to do -8 times -4, which is +32, and then I have the -12. So that's what you should have gotten. Now you have to do this part right. So that would be 16 minus 12. The 4s are correct. So if you got a 4 out, good job. If you did not, please, you got to watch that, because it's that kind of mistake that's going to get you every time. When I don't know why, but when you have the negative out in front like this, it always messes everybody up. So, a good way to check yourself is to make sure that when you plot this point, that it makes sense. Okay, so I have -4, 4. First of all, if the vertex doesn't fit on the grid, that's probably already a sign that something's wrong. But not necessarily. Maybe we just gave you a bad grid. Who knows? But when you plug in the next points, if it's not falling in line and looking like a nice parabola, something's wrong. All right, so there is my vertex. So I have C done. I could do part D now, too. Once you have the vertex, you know part D. I kind of ran out of room, so I'll just squeeze it over here. What would my axis of symmetry be? Yeah, it's always x equals the x-coordinate of your vertex. You don't have to do any more math. You already have it. It's just x equals -4. And then E, would this one be a max or a min? A min this time, because my parabola is going to be, oh wait, did you guys make me say min? It should be a max this time, right? If my parabola is going to be down like a frown, won't that vertex be the highest point I ever get? So it's a max. And F, the y-intercept, that should be easy enough. It's always going to be 0, comma, what in this case? -12. You always plug back into the original. If I plug in a 0 for x, I'm left with a -12. So 0, -12 would be my y-intercept. And now I'm going to sketch the graph. Unfortunately, my y-intercept is so far off the graph, it doesn't help me any. So, oh well, too bad, so sad. I don't get one of those points for free. So, here's my vertex. And then to fill in the rest of the graph, you're just going to go 1 to the left or to the right. Because, right, aren't you going to get the same answer when you plug in -5 or -3? Right? Because they're supposed to mirror over. So it's your choice. Would you rather plug in -3 or -5? I would too. It's a little bit easier, right? So go ahead and plug in -3 into the original and see what comes out. And here is where you're able to tell if you're kind of doing things right. Because if it doesn't look like it lines up properly, then something's wrong. So everybody plug in a -3 into the original. I'm going to do my work over here. Did you get out what I got? I got out this. When I plugged in -3, that's what came out. Once I have that next point, I'm going to go ahead and graph it. So, but this time, -3, 3, I get to buy one, get one free. I didn't draw my axis of symmetry, but I can. Buy one, get one free. Before you move on, you should ask yourself, is this looking like what I thought it would look like? It looks like my parabola will be going down like a frown, which is exactly what I was expecting. If you are plugging the value in wrong and you get a point up here and it looks like it's going up like a cup, you already know something's not right. So stop and fix it. You know this has to be down because A is negative. All right, and then I would plug in at least one more point if I were you. How do I know what point to plug in? That's always a question I get.
What? Oh, the opposite of what the thing equals.
Well, like, what would my next point be that I plug in?
The next, like, X.
Yeah, you're just, here's my vertex. You just go out 1 in either direction to get your first point, and then I go out 2, so I'm going to plug in a -2 or a -6. I'm going to get the same answer for either one, so wouldn't you rather plug in -2 because it's smaller? Yeah, so now you just take -2 and you plug it in and see what comes out. And then I get to buy one, get one free over the axis of symmetry. That's why I don't need to plug in -6 because I'm already going to know the answer when I plug in -2. They're going to be the same. So everybody take a minute and plug in -2. I'm expecting a number kind of down here so that I can mirror it over here. So if I'm not getting an answer around here, something's probably wrong. So everybody plug in -2, please. I got 0 as well, which is fine. So, -2, 0. Buy one, get one free.
Is there no Y-intercept?
There is, it's just, look at where it is. It's at, look at your answer for F, 0, -12. We're not going to be able to see it on our graph, that's all. There is one, we just won't see it. So now connect with a nice smooth curve. Well, it's down like a frown, like we thought it would be. So that's a good sign. Everything's coming up roses. That's it.